Hey guys, it's Mrs. Lamon. I hope this video works out. I've got my St. Patrick's Day shirt going on, so happy St. Patrick's Day. I miss you guys already. Isn't that kind of funny? So here we are, doing our first video lesson. We'll see how it works. We're going to talk about tangent lines and what they are. So I have like a little note thing here. If you want to take notes on this, that's fine. I'm not going to check them. You can use the textbook or write notes from there. It's up to you, however it works for you. So first, when we talk about a tangent line, it is related to the word tangent from trig, but the explanation of that is too long for this video. So I have a video I've watched about that, and I'll try to put a link in there later about why they're connected. So basically, if we have a line that's tangent to a circle, it means it touches the circle at only one point. Kind of like that. That point is called the point of tangency, and that line is called the tangent line. If we have two circles that have the same tangent line, that line is called a common tangent. Circles that don't touch each other can have a common tangent. Circles that touch each other at one point have a common tangent. Circles, looks kind of like glasses. Circles that touch each other like overlapping, they can have a common tangent at the top or at the bottom, kind of like right there-ish. They have a common tangent there. The only ones that really don't have a common tangent, which was brought up in the comments before I even did this video, was if one circle is inside another circle, but they don't touch each other at all. So there would be no common tangents here because any tangent line I draw for the inside one is going to be a chord on the other one. If they do touch inside at one point, then they can have a common tangent at that point, right there. So that's the basics about tangent lines. I'm going to do another video that's going to talk about more details of things we can calculate, but that's the basic of what a tangent line is. Okay, see you soon. Okay, I'm back. Here's the first theorem that the book mentions. It basically says that if this is a tangent line, then it has to be perpendicular at the point of tangency, right there. So that's a right angle right there. If you notice, ST, what kind of part of a circle is that? You can talk to me just like you talked to Dora. What part of the circle is ST? That's right, it's a radius. Good job. So you basically connect the center of the circle to the point of tangency, and that will always make a right angle. The way that they're going to use this is they're going to draw triangles connecting S to some point over here on the tangent line, and you'll have a right triangle, and you have to use Pythagorean theorem and your knowledge of the length of the radius. So it's always going to be a radius from the center to the point of tangency, and that will always make a right angle with a line of tangency. That's what that theorem basically says. I'll show you what the examples are, but that's the general idea. Okay. Okay, so here's the first example that the book has, and some things to pay attention to. First, the question is this line right here tangent? So if they're asking, is it tangent, think about the theorem we just talked about. What are they looking for you to find? Hopefully you've thought about it. They're looking for you to find that this is a right angle. So we have to prove that this is a right triangle. So now you got to think back to previous chapters when we talked about right triangles, and please tell me the theorem that's connected to right triangles. Good job, the Pythagorean theorem. So we're going to do the converse of that here to prove that this is a right triangle. Something else to notice, this 9 is not the center of that segment. It's in the center of this, what we call the exterior segment, because it's outside. So from K to that point right there on the circle, that is 9. So what are they asking, or what is the length of JK all the way? Remember that this is an 8. So you would put an 8 in here because it's also a radius. That trick is going to happen a ton. Sorry, I'm writing upside down and weird. But that's an 8, so this whole thing is 17. So you want to check, is 8 squared plus 15 squared equal to 17 squared? If the answer is yes, then it's a right triangle. If the answer is no, then it's not. We don't care about obtuse or acute here. We just care, is it right or is it not? Okay, I'll send a new video.